This video is still on the chapter of systems of linear equations, and we have been working on this standard form and checking what kind of equations are linear and not linear. So now I have an equation here in the standard form: x plus 2y minus 3z equal 4. And my question is x equal 3, y equal 2, and z equal 1 a solution of the linear equation? So is this a solution of the linear equation? You can see that this equation is linear. Okay, well, it's easy to see that yes, it is a solution, because if x equals 3, so we replace x by 3, then 2, we replace y by 2, minus 3, and we replace z by 1. Let us see if this is 4. So this will be 3 plus 4 minus 3 equal 4. Well, yes, because 3 minus 3, so we have 4 equal 4. So yes, x equals 3, y equal 2, and z equal 1 is a solution for the linear equation. Okay, so if we have a vector u with components u1, u2, un, okay, we say that this vector is a solution, or solves or satisfies the equation f of x1, x2, xn equal 0 if we replace the variables x1 by these values here. So if we do f of u1, u2, un, and we get 0. So if this happens, okay, we say that this vector is a solution, or solves or satisfies the equation. Okay, let us consider now a degenerate linear equation. This is not so simple as it looks at the first sight. So the degenerate linear equation is the equation 0 of x1 plus 0 of x2 plus etc. plus 0 of xn equal b. So we have two cases. If b is not 0, then the equation has no solution. Why is that? Because so 0x1 plus 0x2 plus 0x, and let us say b is 5. Well, there is no 0 times x1 plus 0 times x2 plus etc. plus 0 times xn where you get 5. Okay, this is not possible. You cannot multiply numbers by 0, add them, and get 5. Okay, so if b is not 0, if b is not 0, the equation has no solution. If b is 0, then everything changes, because if b is 0, then every vector in Rn will be a solution for the equation. x1 plus 0x2 plus 0xn equals 0. Any vector you put here, u1, u2, un, any vector you put here times 0, you will be getting 0. So every vector in the Rn vector space will be a solution to this degenerate linear equation. Well, the proof for this would be really easy, right? Because the proof is we pick a vector, any vector, with u1, u2, un, and what we do is we replace it here, right? So that will be 0 times u1 plus 0 times u2 plus 0 times xn, and that will be 0. Whatever the vector is, it will be a solution for the equation. So that concludes the proof. Okay, and this is the proof for 2, right? The proof for 1, it's the other way around. So I'm going to take this, the proof here. So you pick to prove 1 now, where b is not 0. So we don't have a 0 here. We have b, where b is not 0. So we pick any vector u, and we show that no vector can be a solution, because so we take a vector that is supposed to be a solution. So the definition of a vector is u1, u2, un. You put u1 here, u2, so 0 times u1 plus 0 times u2, etc., plus 0 times xn will never be b. So there is no solution for this degenerate linear equation, and that concludes the proof.